All right. It's Trig lecture 11.1 through 11.4. We're actually going to do this for 4 days. Law of sines, you'll run into it a lot, so might as well mess around with it for a few days. The student will use the law of sines to find the lengths of indicated sides and the measures of indicated angles in given oblique triangles. So we're going to be given triangles. They're going to ask us to find angles or sides, and we're going to have to use the law of sines to do it. So here we go. We're going to take a look at them and see how this works. Here's the law of sines. This is just a standard oblique triangle. A is opposite, angle A is opposite side A, angle B is opposite side B, angle C is opposite, side C is opposite angle C. And this relationship exists in the law of sines. It says that A is to the sine of A, so the length of this side over the sine of this angle equals the length of this side over the sine of this angle. You can set up a ratio equal to a ratio, that's called a proportion, and if you cross multiply and you only have one unknown, you can solve for that unknown. And you can set up this one, B, the length of B over the sine of angle B equals the length of C over the sine of angle C. And if you know 3 of these 4, you can cross multiply and solve for the other one. And likewise, A is to the sine of A over the sine of A equals C over the sine of C. And if you know 3 of these values, you can cross multiply and solve for the other one. So you have A is to the sine of A equals B is to the sine of B equals C is to the sine of C. And you can use any 2 of those to set up a proportion and solve for an unknown. So with that in mind, I'm going to use the law of sines and find some unknowns, and hopefully by the time I get done, you'll have a real good idea of how to do it. Here we go. Find the indicated measurement. So I want to find AB. Now that is, AB we remember from geometry. If we're talking about the length of a line segment, and we don't indicate anything up above here, then we read that the length of line segment AB. So I'll look up here. This is the length of line segment AB. It's opposite angle C, so I'm going to call it C. This is what I'm looking for. So I'm going to say that C is to the sine of 17 degrees as, what else do I know here? Well, I know 35 is to the sine of 37. These are 2 that I know that would give me a proportion with only one unknown. If I use this, A is to the sine of A, then I wouldn't know either one of these. So I don't want to use that one, I want to use this one. This is side B, it's opposite angle B, so B, 35, is to the sine of B, which is the sine of 37. So now we have a simple proportion. There are a couple of ways we'd solve this. If I were doing this, we could cross multiply and then divide to get C by itself, but in this case, we could just say, well, hey, this is sine, or C divided by sine 17. We undo divided by sine 17 by simply multiplying both sides by the sine of 17. That will leave C all by itself over here. We don't have to go through cross multiplying since the C is in the numerator of the fraction. And what this will yield is C equals, because these cancel out, 35 sine 17. Remember, there's a 1 under there. 35 sine 17 over sine 37. You can evaluate this with your calculator. Those are degrees, of course. And we'll get C is approximately equal to, and we're going to round it to the nearest tenth, I think. Oh, it just says find the measurement. I'm going to round it to the nearest tenth. Let's see what the answer key does. The answer key looks like it's rounded to the nearest tenth. So yay! So where's my calculator now? Dagnabbit, there it is. Alrighty, so I used the law of sines. I isolated the value that I didn't know, and that is the length of AB. So yay. And that will be 35 sine 17. 35 sine 17. I'm going to just say equals and then, whoops, I'm sorry. 35, I hit the wrong button. Sine 17 equals, and then I'm going to divide that by the sine of 37. Divided by sine 37 equals 35 sine 17 equals divided by sine 37 equals, there we go, 17.0. So that's the length of side C, which is the length of segment AB. So I could make that final statement if I just wanted my reader to be sure. The length of segment AB, which is how we read it when we don't have a segment symbol up above it, the length of segment AB is approximately 17 units. And let me see what my unit of measure is. Meters, approximately 17 meters. And let's see if I got that one right. 17 meters, yay! Okay, so that's how we work it. Let's take a look at another one. In this case, I'm again looking for the length of AB. So I'm looking at this triangle. Here's the length of AB right here, and again, because it's opposite angle C, I'm going to call it small case c, and I'll say C is to the sine of 34. As 14 is to the sine of 37. These are the two I'm given. 14 is to the sine of 37 degrees. I'm going to multiply both sides by the sine of 34 again. To get rid of a divided by sine 34, I'm going to multiply by sine 34. I could cross multiply and then divide. That would just throw in an extra step though. So there's no need to do that. Again, you can think of these as being over 1, and these cancel. And this gives me C is equal to 14 sine 34 degrees over the sine of 37 degrees. And I'm going to evaluate that and round it to the nearest tenth. 14 sine 34, I'm going to say equals and divide by sine 37. That's how I'm going to do it. You can do it with your, there are several ways you can put it into your calculator. I just do it old school because my brain is old. 14 sine 34, hopefully I haven't made any mistakes. Sine 34 equals divided by sine 37 equals, I get 13.0 rounded to the nearest tenth. It'll be 13.0 meters again. So C equals this, or you could say the length of AB, the length of line segment AB is 13 meters. And that's an approximation. And so is this one over here. Yeah, I use an approximation symbol there. Yay! Hopefully that makes sense. This is what we're looking for, and we were asked to find it. We had our tool, the law of sines, that enabled us to find it. And so we're in good shape. Okay. Let's take a look at another one. Here we're looking for the measure of an angle. Up here we were looking for the length of a side. Okay. And our instructions say, or our objective was, students will use the law of sines to find the lengths of indicated sides, which is what we just did, and the measures of indicated angles. So here's how you find the measure of an angle. If you only know one angle, and you're asked for the measure of a specific angle, if you do two of them, you can just add them together and subtract from 180, but we only have one angle. We have some information here. We're going to try to use the law of sines if we have enough information. So let's take a look and see if we can do that. It says find the measure of angle C. So I'm looking for this angle right here. And I can say, well, 11 is to the sine of C. As 27 is to the sine of 88. Just setting up a proportion based on the law of sines. I can set up any of these proportions. I can set up this one, or this one. And so I set up 11 is to the sine of C, as 27 is to the sine of 88, and that gives me just one unknown. Now, I'm going to cross multiply, because my variable's in the denominator. I'll have 27 sine C is equal to 11 sine 88. Trying to isolate sine C, so I'm going to divide both sides by 27. And sine C will equal this mass right here. 11 sine 88 divided by 27. I don't want the sine of C though, I want C. So what I'm going to do is evaluate this, take the inverse sine of it. So I'm going to take the inverse sine of both sides. This will give me C is equal to the inverse sine of this mass right here. 11 sine 88. Those are degrees, by the way. Over 27. And that will equal approximately whatever that happens to equal, providing I haven't made any mistakes. And let's see what we get. And I'll try not to make any mistakes plugging it in. It's easy to make a mistake when you've got big fingers and little bitty buttons. Here we go, 11 sine 88 divided by 27 equals shift inverse sine equals, I got 24.0. Is that correct? I don't know. And that would be degrees. So the measure of angle C, if all of this is true, if that's 88 and that's 27 and that's 11, and we're asked specifically to find the measure of angle C is very, very close to 24 degrees, providing I haven't made any silly mistakes with my finger in my calculator. Let's see what that's algebra 2. That says 24 degrees, and I got 24 degrees, so yay! There we go. That's how you work it when you're looking for an angle. Let's do another one. What am I looking for here? Find the measure of angle B. So in this case, I'm looking for this angle. So I'm going to do basically the same thing I just did. I'm going to say that 5 is to the sine of B. As 23 is to the sine of 107. Degrees. And I use these two because that would, in conjunction with this, leaves me with just one variable, B. Now I'm going to solve it. I'm going to cross multiply 5 sine 107. Degrees is equal to 23 sine B. I don't want 23 sine B, I just want B. So I'm going to divide both sides by 23 and then take the inverse sine of both sides to get rid of that. So when I divide by 23, it'll be 5 sine 107 degrees over 23 is equal to the sine of B. So B will be equal to the inverse sine of this mess. The inverse sine of this. 5 sine 107 over 23 is equal to B. And then we're going to round that to the nearest tenth and come up with a value. So I'm going to try to get this into my calculator after doing this a little bit of algebra here. I cross multiplied. 5 sine 107 is equal to 23 sine B. And I said, well, I want B by itself, so I divided by 23. Then I took the inverse sign. That left me with B by itself, and if I can get this into my calculator without goofing up, that will give me something that I can round to the nearest tenth. So here we go, let's see if I can get it in there. 5 sine 107 equals divided by 23 equals, and I want to take the inverse sign of that, equals, I get 11.99 rounded to the nearest tenth would be 12.0. And that would be whatever unit of measure, inches. So, and I didn't put my unit of measure over here, I should be fired. What was our unit of measure here? Centimeters. Remember your units of measure if they give one to you. So if I haven't made a mistake, this would be 12 inches long. If this side is 5 inches long, and this side is 23 inches long, then that's not inches, is it? It should be degrees. What am I thinking? I am old and tired. We're looking for the measure of an angle. Angles are not measured in inches or centimeters. You have to excuse me. You're probably thinking that. Wade is losing it, and you're right. It's early in the morning. It's my only defense. Degrees. We're looking for the measure of angle B, and we found that this angle would be 12 degrees approximately, providing I haven't made any mistakes, like the mistake I just made calling degrees inches in centimeters. I should be slapped. Now here we go, let's see if I got it right. It says choice D, which is 12. So yay, 12 degrees. So there we go. Sorry about the confusion with labeling my answers. Degrees is what it should be. Why I said inches and centimeters, we may never know. But that's how we do it. That's the law of sines used to find the lengths of a missing side, or the measures of missing angles. And those two things were in our objective. You can do this. We'll do this for a few days.